Are we alone in the universe? Are there other habitable planets? And did Mars ever once have life? Those are the enduring questions for exploration, and I would submit to you all of our exploring in the solar system teaches us about life here on Earth. Our Hubble Space Telescope has now been going for 26 years. Anyone in the audience 26 or younger? Oh my goodness, we got to go to the young global. Come on, we've got to get the young. Because their entire lifetimes, our Hubble Space Telescope, the world's greatest optical observatory, has been searching. It's in low Earth orbit, but it peaks out. So far, we've seen 13.5 billion light years to just understand what is the solar system made of. Again, where are we from, where are we today, and where are we going in the future? My favorite story about Hubble in its 26th year is we pointed it at a very, very dark point in the sky, very dark. You could put up your thumb. Please put up your thumbs. I'm a former academic, and we said, what's behind that thumbnail? It was totally black. Does anyone know what we found? 3,000 new galaxies in that thumbnail. So that kind of changes your perspective on life and vastness. Other highlights I'd love to show with you, James Webb Space Telescope. James Webb will be 100 times more powerful than Hubble. It's in the infrared, and it is going out to search solar system questions, these enduring questions. What about black matter and black energy? We really want to know what that 96% is. It's not quite satisfactory to only know about 4%. So James Webb will be launching in 2018. The mirrors were just installed. 18 articulating mirrors. An engineer like me, the adaptive control, is really incredible. Another of the world's greatest observatories. Were you with us when we went to Pluto? I sure hope so in the last year. We had never seen Pluto. It was pretty fuzzy. We didn't know what it looked like. And we arrived last summer, just a year ago. And we've been zooming in on Pluto, and it's sending data. Look at that. It's unbelievable what Pluto's made of. We didn't know about the mountains and the ice. Plus, Pluto has a heart, which, again, I think is very enduring for the humanity of exploration and seeking new knowledge. How about Dawn? People know about our Dawn spacecraft? It's really the first demonstration success of ion propulsion. It has propelled Dawn to the dwarf planet Ceres. Ceres is in between Mars and Jupiter's orbit in the asteroid belt. And it's been shining at us. What's happening? Well, those are sodium deposits on the far right. That is Ahuna Mons. Move over Mount Everest, because Ahuna Mons is 5 kilometers tall and 20 kilometers wide. And we didn't even know there were any volcanic structures on these other planetary bodies. So every day, I think I have the world's best job. I get to learn about the science. Where will you be in a week? July 4th is kind of an important day in the US. And thanks to the US for throwing us a big party at NASA, because our Juno spacecraft reaches Jupiter orbit. We're starting orbit insertion right as I speak. In 1 week, we'll be the closest point humanity has ever been to the giant planet. And my favorite instrument on Juno is called JunoCam, and it's citizen science. Hey world, where do you want to explore on Jupiter? And we point JunoCam wherever you tell us to. So it really is global exploration. It's for everyone to put eyes on Jupiter. We're going to stay in orbit for the next 20 months, exploring Jupiter closer than we've ever been before. Maybe you know about OSIRIS-REx. OREX is going to launch in September. For the first time, we'll go out, we'll take a sample of the asteroid. It takes a few years, as all space missions do, and we'll get it back in a few years to see the constituency of the asteroids. Maybe you heard that we found water. We found seasonal water on Mars. That was a huge scientific discovery. We knew there were polar caps. We're going to Mars to search for past evidence of life. So we knew there was ice in the polar caps, but this was phenomenal. Seasonal, flowing, very briny, salty water. You don't want to drink it yet. I want to show you a simulation. We now know how Mars probably lost its atmosphere. Earth and Mars, sister planets, 4.5 billion years old each. 3.5 billion years ago, we think something went terribly wrong at Mars. It probably was wet, warm, wonderful. This is a simulation of the solar winds, the solar radiation, the solar bombardment of Mars, and these are literally the ions ablating off of Mars. Mars losing its atmosphere because of the strong solar winds and radiation. So MAVEN took this recent data, giving us a clue of how Mars likely lost its atmosphere. But I want to tell you what we've been doing for the last 50 years on Mars, because we've sent rovers and landers. So here's a highlights reel of the last 50 years of Mars exploration with our probes.
blaze the trail for human footprints on Mars.
I just wanted to call and say congratulations to the entire Mars Science Laboratory team and really all of JPL. You guys should be remarkably proud.
So that's my job, get people to Mars in the 2030s, based on all this incredible success. So we have a plan and a strategy. This is the NASA plan for humans to Mars. It's 3 phases. I like to explain it: Gemini, Mercury, Apollo, 3-phase plan. We are currently in the first phase. We're on the International Space Station with our partners, 16 years continuous orbiting low Earth orbit. Only takes 90 minutes to go around, so you get beautiful sunsets and sunrises every day, and we're buying down the human health risks that I'll tell you about. After space station, we move from beyond low Earth orbit. We have space station until 2024, but in 2018 we first launch our Space Launch System, which I'll highlight in a minute, with the Orion capsule on top. We go to Earth-Moon orbit. In cislunar space, we spend the next decade buying down the technology risks. I'll tell you about the technologies that we're most interested in. That's how we learn. 3rd phase, we finally get to Mars orbit and into Mars by the 2030s. So that's our plan. We're saying, hey, this is what NASA, we can do in our budget, and the world, where do you want to partner? Put your elements on here, because we're all in, and we want partners from everywhere in the world. This is global exploration, and we want the world to join us and come with, and whatever the world wants to lead, that'd be great. You know, put your building blocks here, because that's how we go to Mars, is with humanity. On space station, as I mentioned, it's amazing that we've been there for 16 years continuously. There's been over 200 astronauts from many different nationalities. Each 6-month increment, we do over 200 science missions. And Scott Kelly's mission you might know about. That's our longest yet. Our 1 year on space station with his colleague Mikhail Koryenko of the Russian Space Agency. So Scott and Mikhail together, over 400 science experiments, and also technology demonstrations, which are so critical. Mars is a horizon goal. What do we need to do and learn in Earth-Moon orbit? What can we learn today on space station? That's how we approach it. What science, what technology, what can we learn about today that helps us further our mission? Here's some of the technologies that we're testing: extravehicular activity systems, life support systems, habitats. You might know we just expanded the beam habitat. We have to figure out, how do we have habitats in deep space? We don't know yet. The life support systems on space station are excellent, but we have to close the loops. The most important technology for Earth, closed loop life support systems. Can we close the air loops? Can we close the water loops? Recycle 100%. We're not there yet, but those are the technology investments that we're making for the future. I asked Scott, what technology do you think we should invest in for our journey to Mars? And here was his answer. You can follow me, I'm at Deva Explorer, so here's his tweet.
Yeah, I think the life support systems that we need to keep us alive in space are ideal candidates for demonstrations for our future journey to Mars, as well as space suits. We need, I think, new spacesuit technology that requires less maintenance in space. And something that's going to be easier to work in on the surface under the Martian gravity.
So all of our work, technology investment, again, thinking today, but thinking out for the next 2 decades. I want to highlight what I call the new NASA, our public-private partnerships. We have over 700 partnerships with 120 nations. In the US, we're betting on our commercial companies. NASA's not doing everything anymore. We're servicing, so SpaceX and Orbital ATK are delivering cargo to space station. They both had accidents, they're back up, spaceflight's hard. They've both returned to flight, they're carrying our cargo to space station today. We have a next launch next week. The Russians, our colleagues, our most important colleagues in this partnership, 16 years of soft diplomacy, carrying cargo and carrying astronauts. Japanese are great partners. The Japanese are committed, extending space station to 2024, carrying cargo as well to space station. We're all in it together. We need everybody to succeed, private industry and world governments. I want to tell you about 2nd phase of our journey to Mars, the proving grounds, going to Earth-Moon orbit. We go on this very large rocket called the Space Launch System. It's big, it's audacious, it's more powerful than the Saturn V. It's pretty exciting how much development we have going on. Tomorrow, we're going to fire some tests. So here's the reality of it. We have 1,000 1,000 different companies working on this project in every state in the United States. Just for exploration mission 1, that's 2018, we'll be flying into Earth-Moon orbit. So that launches in 2018, and then early 2021 is the first astronaut mission, and then we go every year in the 2020s to test out the technologies to get into Earth-Moon orbit and then onward to Mars. Mars is hard. It's really hard. So in human history, we've been trying and trying. We just first tried to get there and fly by. The world has been trying. And then we had some successes in orbiters and landers and finally rovers. But I want you to see from 2000 on all those green checks and point out the Indian Space Agency, first attempt, MOM, I love that acronym, the Mars Observer. They're in orbit around Mars today. We give them our deep space network, the navigation. Everyone's success is all of our success. ExoMars, that's a European mission, launched on a Russian launcher. It's en route to Mars today. So the point is that we're all in this together. It's very exciting. So we know how to land 1 or 2 metric tons. It's game-changing to land 20, 40 metric tons when you talk about a human mission. These are the technologies we're investing in today to get it right. You saw a lot of fire in my video. As a rocket scientist, that's what we like. But at entry, descent, and landing, coming in hot, Mars's atmosphere, 1%, it's just a nuisance. It's not enough. There's no drag in that. So we come in hot, and we have to figure out, we've tried to land every which way we can. But now we're coming in with 10, 20 metric tons. We don't know how to do that yet. In situ resource, all successful exploration in human history has lived off the land. How are we going to live off the land in Mars? We have a maker, but on Mars, the maker has to make itself. Then we'll have a maker. We can't bring it with us. So we have some pretty challenging questions. Once we land successfully with our human astronauts, then we have to ascend. It is a round-trip mission. It takes about 8 months to get there with conventional propulsion. It'll be about 2 years in orbit, full round trip, and about 600 days on the surface, again, to search for the evidence of past life, if our rovers haven't already found it. So I put this up just again to highlight our next big rover is Mars 2020. Instruments from all over the world. We have the global exploration roadmap where we say, let's think about it. All the space agencies are in. It's global exploration for the world. So now I want to put our focus back down to Earth. Spaceship Earth, as I love to call it, coined by Buckminster Fuller. That is the far side of the moon. We see it from, this is our Discover mission, Earth and the sun. There's this really beautiful point halfway in between. It's the Lagrangian point. We call it L1. It's gravity neutral. So it is literally a great place to go hang out. So I call it a space weather buoy. So Discover mission is 1 million miles away, 1.6 million kilometers away from Earth, and it's looking at the solar radiation, the solar wind, saying, hey Earth, this is what's coming your way. So it's our solar system weather buoy out there looking at, again, at so every month we get to see, it's my new screensaver, because we get to see the far side of the moon. Currently we have 20 Earth satellites in orbit looking at temperature, looking at sea rise, looking at land, looking at soil, looking at moisture, looking at everything we can. Eyes on Earth. Critically important, critically important. If there's a natural disaster, we can put eyes on Earth. Anywhere in the world, we look and put all of our assets to try to give the data, try to give real-time data. Most recently, the great forest fires in Canada. We put all of our assets and try to give images so that we can help any way that we can. Again, huge international cooperation, and the data is open. Share the data with the world. I want to show you a century of climate data. Blue, 1 or 2 degrees cooler than the average in recorded history of climate. Yellow and orange, 1 to 2 degrees Celsius warmer than the average. You can raise your hand when you're born. It's my audience participation time. You guys are all younger than me. 2015, the hottest year recorded ever. We have the data for 2016. I just got the May data, broke all records. We look month by month. We are in an exponential curve for 2016 to be yet another hottest year. So I'll finish on some beautiful imagery. This is real science, this is real data, but this is a perspective that we get from our orbital view looking down on Earth. You might recognize, this is China. We have Africa, we have Algeria there. Our coldest continent, Antarctica. Anyone from South America? That's what the Nazca lines look like from orbit in Peru. The artists have always been with us on this journey. So Warhol to Annie Leibovitz, who took this photo of Eileen Collins, our first female shuttle commander. So again, we're all in. We need everyone. That's my job, get people to Mars in the 2030s.